guys. What do you notice this time we gave you? What two sides? A and C, didn't we? Okay? We give you the length of one leg, and we give you the length of the hypotenuse. We're going to try to find the other leg length, in this case, the leg B. So we start with always writing down what first on our board, on our paper? A squared plus B squared equals C squared. Right. Write down the thing in here first, and let's plug in what you're given. We're given A, which in this case is 4 what? Squared. Plus, we don't know B. So just write B squared equals, and we do know C is what? 9 squared. So all we're doing is plugging in what we know. Let's simplify as much as we can. What's 4 squared? 16. Plus B squared equals 9 squared? 81. Now, to solve for B, we need to get rid of what on the left side? This, not yet. The 16. How do we get rid of adding 16? Subtracting. So the key is here, class, when we give you a leg and the hypotenuse, you're going to end up having to subtract the leg you're given squared from the C squared, and then take the square root of both sides. We're going to subtract 16 from both sides, and we get B squared equals 65. Good. How do we get rid of now a square?
You have the square root.
Take the square root, right, Tom? Take the square root of both sides. We get B is equal to the square root of 65. Now comes the part what's very, very important. You guys learned in 11-2 how to simplify radicals. Okay? I don't want you to take the square root of 65 and give me a decimal answer. We want to simplify using simplifying radicals. Now, tell me right now, is 65 a perfect square?
No.
It's not. Does it have any perfect square factors? So this is when you should be looking at your factor sheet side. Look at 65 and tell me, does it have any perfect square factors?
No.
It doesn't, does it? Okay, so therefore, is this radical simplified?
No. But yeah.
Yes, it is, because one is not a perfect square, and two, it doesn't have any perfect square factors. So leave your answer as the square root of 65, unless they tell you to do otherwise. I want you to simplify those radicals in simplified radical form, okay? All right, how does those two first examples feel good? So when we give you two legs, or when I give you a leg and a hypotenuse, two different examples, but you still use the Pythagorean theorem. Now the third one we do here, this is going to be the hardest one you see today in terms of examples, but I want to make sure I go through this because it's something we're going to ask you to do in your homework, and it's going to be in your tests and quizzes to make sure you understand how to do one a little bit. It's obviously a little bit more out of our comfort zone in terms of how to do it, but again, it still follows using Pythagorean theorem.